Hello, beautiful people. Future me. Welcome to another programming workout of mine. You know the drill, probably. The typing will be the first thing I do, and my crap. Here we go. In my programming workouts, it will consist of 30 minutes concentrated work, hopefully concentrated. First, I will do 5 minutes of typing, if I said it or not already, and then 25 minutes. And today, or in this programming workout, we will be doing spring. Ready? Let's go. I'll start the timer. The main thing I have to remind myself is to keep the errors are lowest. So anything I'm aiming here for is to do least possible things. That's the number one priority. Then nothing, and then speed. Oh, crap. You know what they say? If you train crap, you will be crap master. I don't want to be crap master. I will finish it. I feel tension in my left arm. Maybe I have to change my layout. Okay, so equal sign is here, here, that, this, okay. Type equals 0. What? Oh, yeah. Why he changing styles? This here he doesn't have spaces, and here he use spaces. Damn you! I like consistency. What can I say? Ah, crap. All right. I hope for the least percentage there is a few 2%. 2% is good for me. So what did I did? Okay, so I mistyped this E Z O P. O I did multiple times. I pressed P instead. 1, 2, 3, 4. So the red one is the error, and the orange is which I kind of did in the speed. How they collaterally typed before backspacing. Okay, so backspace is 20. Okay, so here's 1, 2, 3, 4, 5, 6, 7, 8, 9. And there, oh, there's more. There's R, there's a quote. All right, all right. Okay, so 15, 4. So this makes for extra, that is what, 35, 39 extra key process. And 1700, well, that's kind of good. That's kind of good. Anyway, this timer says that we are way over the time for the typing, so we will start the timer for the other part of the programming workout, which in my case, I mean, well, at least for today, it's a Spring. I'll open my notes and see what is there. Transaction management. All right. So here's transaction management, and I should continue in programmatic versus declarative. All right. So programmatic versus declarative. I think I read this yesterday, and programmatic should be that you kind of write SQL yourself or whatever. Declarative, you, I don't know, use some like pre-built queries. They set annotations or XML. Yeah, so that's probably how it's done. And I still need some examples, I think. So now what I do in here or in that, or okay, well, I open it so I don't forget about it. So I don't forget about it. And then okay, so with the help of programming, that gives you extreme flexibility, but it's difficult to maintain. Okay, so that's the programmatic transaction management and declarative transaction management. Okay, so we are still in the transaction management. So, and I'm still not entirely sure about the transactions. I'll see. This means you separate transaction management from the business code. You only use annotations or XML-based configuration to manage the transaction. Declarative transaction management is preferable over programmatic transaction management, though it's less flexible than programmatic transaction management, which allows you to control transactions through your code. But as a kind of cross-cutting concern, declarative transaction management can be modularized with the AOP approach. For the fuck's sake, I'm supposed to be in a bank and I forgot about it. Oh, tomorrow is day 2. All right. All right. This means blah blah blah. Where I'm. But as a kind of cross-cutting concern, declarative transaction management can be modularized with the AOP approach. That was aspect-oriented programming. Spring supports declarative transaction management through the Spring AOP framework. Spring transaction abstractions. Okay, so here is what we continue in. Okay, now what do we have? The key to the Spring transaction abstraction is defined by the OrgSpring framework, transaction platform, transaction manager interface, blah blah blah. Okay, which is as follows. So we have an interface. Platform transaction manager is the name of it. And transaction status, get transaction. Transaction exception. Wait, commit. Commit, and we have a commit, we have a commit, and we have a rollback, and both of them are throwing a transaction exception and accepts transaction status. Huh. Okay, so the get transaction And we put in the transaction definition. This method returns a currently active transaction or creates a new one according to the specified propagation behavior. Okay. The commit, the void commit, transaction status. This method commits a given transaction with regard to its status. A rollback, this rollback. Okay, so we create or get the current one by get transaction. Commit is I just commit, and rollback is go back or something bad happens. All right, so the transaction definition is the core interface of the transaction support. Core interface for the transaction support in Spring and it's defined as follows. Okay, so this is like what they used in here, and the transaction definition have few fields. Okay, so that's just data. No, it's they are methods. Okay, and it's returning int. And in interface, in Java, everything is abstract and public by default. I think it's public. So get propagation behavior, get isolation level, name, get timeout is read-only. So those are basically just getters. Everything like, yeah, this doesn't say get, but you know, Java, it's spooling, so it's this. Get propagation behavior. This method returns a propagation behavior. Spring offers all of the transaction propagation options familiar for AJBCMT. AJBCMT, I have no ID. What is that? Well, let's get on. Let's get on. Get isolation level. Now we are going deep. This method returns the degree to which this transaction is isolated from the work of other transaction. What? All right. I don't get it. I don't know what it is. Moving on. String get name. That one I returns. That one I can understand. Returns a name. String. Good. We are done. Moving on. Get timeout. This method returns the time sequence which the transaction must complete. Yeah, so it will be, okay, it's, does it? I wonder if this change, if it's like counter and it decreases with the time, or that's just the entire like block of time which is reserved for the transaction. I don't know. Is read only. Returns whether the transaction is read only. Okay, so that is self-explaining, and by read-only, I would expect that the SQL queries which are actually executed would be read-only. No, at least that's my idea, my imagination. Okay, following are the possible values of isolation level. Okay, so that was the first thing, right? Okay, it was the second thing. So, default, read committed, read uncommitted, repeatable read serializable. Huh. Okay. Default is default. All right. Uh, thank you for explanation. Indicates that dirty reads are prevented. I would think that the dirty reads yeah, in SQL would be to read while something else is like yeah, it's permitted to read data that is being modified by another transaction which is running currently but which has not yet committed itself. If the transaction that modifies the data commits itself, the dirty read problem doesn't occur. If the transaction that modifies the data commits itself, well, seems to me that is like the race condition in Java, which means that uh, like the transaction A reads something, then the transaction B comes in, reads the value as well. Then the transaction one says like, oh yeah, let's say the amount should be something, the value which we read plus one, right? Then it saves it to the SQL, so it will be 1001, for example. But then the second one comes in, and that didn't read the 1001, right? That read the 1000 before it was written by the transaction A. So, and the second one has to add like 2, for example. So if we had two transactions and one would add 1 and the second one would add 2, the intended behavior would be to have 1003 in the end. But what will happen in here is that the thread number 2, not thread, transaction number 2, did not get the updated value, right? So it takes the 1000 which we read before the thread, not thread, transaction A committed back, and add 2 to that. And then that will try to store that in SQL, successfully so. So in the end, we will have the 1002 in the respective field, which is undesired behavior. So the dirty read is reading where you shouldn't, in short. All right. So good, we explained that. Non-repeatable reads and phantom reads occur. Dirty reads are prevented, non-repeatable reads and phantom reads. Okay, so non-repeatable reads something. SQL. No, SVL doesn't mean everything. Yeah, thank you. You know what I mean. Non-repeatable read is one of in which data read twice inside the same transaction cannot be guaranteed to contain the same value. Depending on the isolation level, another transaction could have. Okay, so that's some kind of like SQL thingy, the isolation. Oh boy, I need to learn much more. Okay, and then we had the phantom reads, which is my favorite already because of the name. Phantom read occurs when one user is repeating a read operation on the same records, but has new records in the result set. Read uncommitted, also called a dirty read. When this isolation level is used, a transaction can read uncommitted data that later may be rolled back. Okay, so phantom read is... What is the difference between dirty read and phantom read? Okay, so phantom read is actually the result of the dirty read, also called a dirty read. Okay, so here they are saying I would also understand it that yeah, as it say, new rows are added occurs when the course of transaction new rows are added or removed by another transaction to records being read. Okay, so I read twice and someone changed it. So thread A reads once and there's a 1000. Thread 2 put in the 2, so it will be 1002. Thread A reads again, has 1002. Same query, but it gets two results. Once it was 1000 and the second one was 1002. So that, to my best understanding, is phantom read. All right, moving on. Bum bum. Transaction definition. isolation read uncommitted indicates that dirty reads, non-repeatable reads. God damn it, what was the non-repeatable read? In SQL. Non-repeatable read is one in which data read twice inside a transaction cannot be guaranteed to contain the same value. Okay, so that's like the phantom read. Okay, non-repeatable. So phantom read is when it occurs actually, I think. Non-repeatable would be like you shouldn't do it, I guess. Go on. And phantoms, okay. So can occur. What's the okay, read committed. Okay, so dirty reads are prevented. And those two can occur. Okay. So that means okay, dirty reads are prevented. Non-repeatable reads and phantom reads can occur. Okay. How is that even possible? Indicates that dirty reads. So isolation read uncommitted is like everything goes. Then isolation repeatable read is that dirty reads and non-repeatable reads are prevented, and phantom reads can occur. I thought it's the same thing. Okay, I don't understand it correctly, apparently. It will be something different. But everything turns around, like the race condition, whatever. Okay. Then we have serializable. Indicates that dirty reads, non-repeatable reads, and phantom reads are prevented. Okay, so it goes from here. This one will be like, I don't know, everything goes. Dirty reads are prevented, dirty reads, non-preventable reads, and then this is prevented, then okay, so default is default. I don't know what the default is. It's default, okay. So that tells me nothing. This one is okay, so I would say uncommitted first because that is like everything can occur. Then I would say isolation read committed because why is this 1 second? Doesn't make sense to me. The dirty reads are prevented and non-repeatable and phantom can. And repeatable read is like everything can occur, which is dirty read, non-repeatable reads, and phantom reads. And serializable is everything is prevented. So this would be first, I think, in my, like, why, how they are like sorted? Is it like alphabetically? Committed, uncommitted, repeatable. Yeah, it's alphabetically sorted. All right. All right. All right. All right. Whatever. Jenny would be happy. Following are the possible values for propagation types. What is propagation type? Supports current transaction, throws an exception if no current transaction exists. Propagation mandatory. propagation nested executes within a nested transaction if current transaction exists. Okay, transaction definition never does not support a current transaction. Okay, what? Propagation not supported, does not support current transaction, rather always executes non-transactionally. Okay, supports current transaction, creates a new one if none exists. Required. Creates a new transaction. Suspending the current transaction if one exists. Okay, requires new. Okay, that one I can understand. Propagation required that I can it will create transaction supports a current propagation supports current transaction executes non-transactional if none exists. Okay, supports that means not required. Like if there is some, like we are okay with it, but if not, we create. We are good. And timeout default uses the default timeout of the underlying transaction system, or none if timeouts are not supported. Transaction status interface provides a simple way for transactional code to control transaction execution and query transaction status. So here we have 4 getters and one setter. Rollback only. Okay. Boolean has returns whether transaction internally carries save point. Ah, yes, I have some save points. Interesting. Okay. Boolean is completed. This method returns whether this transaction is completed, i.e. whether it has already been committed or rolled back. Is new transaction? Yeah, if it's new. What does it mean new? Anyway, like nothing has been changed on it. Like when we decide that it's not new anymore. Rollback only. Succession had been marked as rollback only. Says rollback only. Okay, so I think I want to have a look in the programmatic and declarative transaction management. So I will take this and yank, and I'll say here, and this one. Oh, come on. Bam. And I definitely need to, well, change my Emacs. I do a lot of stuff. Alright, change my Emacs config and change my keyboard layout. Oh, too much stuff to do. Oh well. Programmatic transaction management, and we have a few seconds to go. Whatever. Programmatic transaction management approach allows you to manage the transaction with the help of programming in your source code. That gives you extreme flexibility, but it's difficult to maintain. Yeah, more code, more difficulties to maintain. Before we begin, it is important to have at least 2 database tables on which we can perform various CRUD operations with the help of transactions. Let us consider a student table which can be created in MySQL database with the following DDL. What is DDL in SQL? DDL in SQL. That will be something. Okay. In SQL. So what does it mean? Data definition language. All right. Data definition language. We have some nice things. If I remember, the Geeks for Geeks were pretty nice site. Cookie. Nom 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 nom. Data definition language, data query language. Duku I. This is supposed to be L, right? Add notes, feedback based. Huh. And you can practice this. I think I like it. Anyways, this guy shows us that we are over the time limit. That means we are done. Done is better than perfect. And I will see you next time. Have a nice day. Bye.